As I speak, the vehicle is in great shape for meeting the opening of our launch window on the 8th. This will be an evening launch, so we launch into the night side of the Earth and head out over the Atlantic. About 2 minutes after liftoff, the single solid rocket booster will be jettisoned. About 4 minutes after liftoff, after expending 26 gallons of rocket fuel, the first stage will be jettisoned. Roughly 30 seconds later, the fairing, or nose cone, is jettisoned. We hang on to the Centaur upper stage. I'm getting ahead of myself. Yeah, there's the fairing. We hang on to the Centaur upper stage until we are in view of Canberra Ground Station in Australia. Then we separate from the Centaur. You can see the various orbits as Bennu and the spacecraft and the Earth move around the sun. After launch, we'll perform an Earth gravity assist to change the orbit plane. We use the energy from the Earth's gravity to perform this change. As we approach Bennu in August of 2018, we will perform long-distance imaging. We're looking for small natural satellites, dust or gas plumes from the asteroid, anything that could pose a hazard to the spacecraft. During the global mapping phase, we will perform extensive characterization of Bennu's entire surface, especially using our 2 spectrometers to map the mineral distribution across Bennu. During sample site mapping, we will get detailed information about the site to be sampled. When OSIRIS-REx is ready to sample, the TAGSAM arm and sampling head will be deployed and placed into a sampling configuration. You will see that in the next couple of seconds in the video. As I proceed through the rest of the sampling collection, you'll see images of our testing that we've done with our actual sample head. And there it is in its sample configuration. As we approach the surface of the asteroid, we approach at a velocity of 10 centimeters per second, which is a very slow approach. When contact is sensed, a gas bottle on the TAGSAM arm is discharged that agitates the surface material, causing to expand up and into the collection chamber, the outer ring of the sample head. In addition, 24 contact pads made from stainless steel Velcro are on the base of the sample head. Once we have assessed that we have collected the sample, the head will be stowed into the sample return capsule. You can see that opening up now. Separation bolts are fired to disconnect the head from the TAGSAM arm. As the asteroid departure maneuver is performed, it sets us up on a trajectory to intersect Earth 2.5 years later. About 4 hours after atmospheric entry, we spin up and eject the SRC targeting the Utah Test and Training Range, located just southwest of Salt Lake City. The SRC re-enters at about 27,000 miles per hour. The team follows similar SRC procedures as were used in the Stardust mission. And this is actual footage from the Stardust SRC recovery. Once the OSIRIS-REx capsule lands safely in the Utah desert, the team will recover it and deliver it to the NASA Johnson Space Center in Houston. Here's the Stardust SRC as it is opened. These are the images from the TAGSAM head ground testing. The head is about 1 foot across, so the test sample represents quite a bit of sample return. The global science community will be thrilled with this amount of asteroid regolith that they will be able to study for decades. Thank you from the OSIRIS-REx team supporting our mission. We look forward to a successful launch on Thursday. We hope you enjoy touring the Visitor Center complex and seeing the launch. A lot of people have worked very hard on this mission, over 5 years to get to this point. And although the work is challenging, we also find it fun and exciting. We're glad that you can share a piece of this excitement with us. Thank you very much.